In the summer of 1944, the war in Western Europe had entered its decisive phase. The beaches of Normandy were no longer battlefields of uncertainty but gateways through which the Allies surged into occupied France. The German army, reeling from the surprise and the scale of the invasion, began retreating inland, leaving behind shattered equipment, scattered papers, and the debris of command. Near Saint-Lô, in the chaos following an ambushed Allied supply column, a group of Luftwaffe officers stumbled upon several weathered map cases marked with the insignia of the U.S. Army Map Service. The documents inside seemed ordinary at first: folded sheets, printed grids, contour lines, and coastal markings. But when they spread one open across the hood of a truck under the dim light of dusk, what they saw froze them in silence. The map was flawless. Every hedge, farmhouse, and barn appeared with uncanny precision. Contours followed the rolling hills exactly as they stood before them. Roads bent with mathematical perfection, even the smallest tree line matched the real landscape. It was as if the Americans had redrawn France itself, not from memory, but from the heavens. One officer, an experienced reconnaissance pilot, whispered in disbelief, "Kein Mensch kann das so genau zeichnen." No man could draw this so precisely. They were looking at something they did not yet understand, a new kind of weapon, one born not from gunpowder or steel, but from light and geometry. These maps were not drafted by surveyors on the ground. They were built by airplanes, by the eyes of machines flying miles above. In that single discovery, the Luftwaffe confronted a quiet revolution that had already tilted the balance of the war. While Germany had spent years perfecting aerial tactics, dogfights, bombing runs, radar interception, the Allies had mastered something far subtler: the power to see, to measure, and to map the world with a precision beyond human reach. What those officers held that evening was more than paper. It was evidence of an invisible campaign, one waged by unarmed aircraft, film cameras, and mathematicians who had turned the sky itself into an instrument of intelligence. They did not yet know the word for it. But the Allies did. They called it photogrammetry, and it was already rewriting the battlefield below. Before the Second World War transformed the skies into battlefields, maps were the slow work of human hands. Every contour, every river bend, every elevation line was the result of months, sometimes years, of field surveys carried out by men on foot with measuring rods and compasses. Surveyors braved deserts, forests, and mountains to triangulate the Earth's surface, recording their data in leather-bound notebooks. From those raw measurements came the maps that guided soldiers, engineers, and explorers alike. They were products of endurance, mathematics, and artistry, but also of limitation. In the First World War, those limitations became deadly. On the Western Front, artillery depended entirely on accurate coordinates. Yet even the most carefully prepared maps often proved unreliable once the landscape was churned by shellfire. Trenches moved, landmarks vanished, and survey teams were forced to crawl under fire to remeasure ruined ground. Historians later estimated that nearly one-third of early artillery barrages fell short or overshot their targets due to outdated or imprecise maps. In the years that followed, military planners understood a simple truth: the army that saw most clearly would win. By the late 1930s, mapping had entered an era of scientific modernization. Civil engineers in Europe and America began experimenting with aerial photography as a way to cover vast territories in record time. The technique was not new. Balloon photographs had been taken as early as 1858. But the quality of the images had finally caught up with theory. Specialized cameras mounted in aircraft could capture overlapping photographs at fixed intervals, each image overlapping the next by 60%. When viewed through a stereoscope, the two images produced a three-dimensional illusion of depth. This was the foundation of photogrammetry, the science of deriving measurements from photographs. In Germany, the process was known as Luftbildmessung, literally, air picture measurement. Civil firms such as Carl Zeiss Jena and Wild Heerbrugg manufactured precision instruments to interpret aerial photos for peacetime cartography. Yet even with this head start, pre-war German doctrine still viewed aerial photography primarily as reconnaissance, a way to locate targets, not to redraw the landscape. The Allies thought differently. In Britain, the Ordnance Survey and Royal Air Force had begun integrating air photos into map production by 1938. Across the Atlantic, the U.S. Geological Survey and the U.S. Army Corps of Engineers were experimenting with vast aerial mosaics covering entire states. These civilian initiatives quietly built the foundation for the wartime mapping revolution to come. When war erupted in 1939, both sides raced to adapt aerial imaging for strategic use. German aircraft like the Dornier Do-17 and Heinkel He-111 carried cameras to photograph enemy positions, while British Spitfires began their first reconnaissance flights across the Channel. But there was a crucial difference: the British were not just photographing, they were measuring. Under the direction of the Air Ministry's Directorate of Photographic Reconnaissance, scientists at Cambridge and Oxford refined methods for translating photo angles into ground distances. By 1941, these innovations converged into a new idea: maps could be generated directly from the air without ever setting foot on enemy soil. In an era when intelligence often arrived too late to matter, such accuracy promised a new kind of superiority, one that would not depend on luck or spies, but on geometry and light. Yet this leap required an extraordinary alliance between technology and art. Cameras had to withstand freezing altitudes and violent maneuvers. Film emulsions had to capture microscopic detail through haze and cloud. Pilots had to maintain exact flight paths so that overlapping photographs could be compared. Every variable, from altitude to lens distortion, had to be calculated and corrected. It was meticulous, invisible work. But for the Allies, it would prove as decisive as any bomb or bullet. When the United States entered the war in December 1941, it brought industrial capacity and scientific organization on a scale the world had never seen. One of the first priorities of the newly formed U.S. Army Air Forces was to expand its cartographic branch into a dedicated global network, the Army Map Service, headquartered in Washington, D.C. Its mission was not just to print maps, it was to redefine how they were made. At the same time, the British were already running an extraordinary operation out of a quiet country estate west of London. The house was called Medmenham, and it served as the Allied Central Interpretation Unit, the nerve center of the world's most advanced aerial reconnaissance program. Here, mathematicians, engineers, and pilots worked side by side in what historian A.P. Ryan later described as a cathedral of geometry and light. Every day, aircraft from the Photographic Reconnaissance Unit, PRU, returned from missions over occupied Europe with canisters of film. Within hours, those negatives were developed, mounted, and examined under stereoscopes that transformed flat photographs into solid, measurable terrain. The British leadership understood something profound, that victory in modern war depended not merely on knowing where the enemy was, but on knowing the shape of the ground itself. By late 1942, the PRU had mapped large portions of Western Europe with a precision that defied wartime conditions. Factories in Bristol and Fairford produced custom-built aerial cameras with lenses ground to tolerances of 1/1000th of an inch. Technicians calibrated them for distortion so that every frame could be mathematically reconstructed into true scale. The Americans, observing Britain's success, expanded the model into something even larger. By 1943, the U.S. Army Air Forces had established entire aerial mapping squadrons equipped with Lockheed F-5 Lightnings, reconnaissance variants of the P-38 fighter stripped of weapons and fitted with vertical and oblique cameras. These unarmed aircraft flew at altitudes exceeding 30,000 feet, photographing enemy territory from the Bay of Biscay to the Rhine. Their mission code was Project Casey Jones, a vast enterprise to capture overlapping photographic coverage of every potential invasion zone in Europe. At its peak, Project Casey Jones produced hundreds of thousands of negatives per month. The resulting film was flown to England and processed in enormous darkrooms where analysts worked around the clock. In one surviving photograph from the Medmenham archives, rows of officers in shirt sleeves lean over illuminated tables, tracing riverbeds and elevation lines from paired photographs. The process was painstaking but revolutionary. Two overlapping images, taken seconds apart, allowed interpreters to measure height and distance to within a few feet. This information was fed into a growing geodetic network connecting London, Washington, and Ottawa. Engineers at the Army Map Service used it to correct old pre-war charts, while draftsmen converted it into thousands of standardized sheets under the designation GSGS 4347, the map series that would guide Allied forces on D-Day. Meanwhile, German reconnaissance units struggled to match such precision. Limited by fuel shortages, camera film scarcity, and decentralized production, their mapping operations lagged months behind. The Luftwaffe still relied heavily on human interpretation and manual drafting. The Allies had mechanized both. By 1943, Allied cartography had evolved into an industrial science. Geography, once measured in miles, was now measured in pixels of light and silver halide. Every photograph was a data point, every flight path a survey line, and every camera a new kind of weapon, one that fired not bullets, but information. What began as a scientific curiosity in civilian laboratories had become one of the most decisive intelligence revolutions of the war. The age of mapping by hand was over. The age of mapping from the sky had begun. By early 1943, Allied intelligence was preparing for a future invasion of Western Europe that required an entirely new level of precision. The campaign would involve thousands of ships, hundreds of thousands of men, and equipment that depended on knowing not just where the enemy was, but the slope of a beach, the depth of a river, the height of a hedge, and even the density of a French country road. Traditional maps could no longer serve that purpose. What the Allies needed was a new language of war, drawn not with ink but with light. That language became Project Casey Jones, the largest aerial mapping effort in human history up to that time. Named after the legendary railroad engineer who knew every curve of the track, the operation's purpose was to know every contour of Europe. Overseen by the Army Air Forces Aeronautical Chart Service and the Army Map Service, Casey Jones united dozens of reconnaissance squadrons, laboratories, and printing facilities under one mission to remap the continent from the air. The project's flying workhorses were the Lockheed F-5 Lightnings, sleek, twin-boomed aircraft derived from the famous P-38 fighter. These planes were stripped of guns to save weight and equipped with multiple cameras mounted in the nose and fuselage. Each carried a complement of Fairchild K-17 or K-22 cameras capable of shooting 9-inch negatives through precision ground lenses. At 30,000 feet, they could capture an area spanning 20 square miles per frame with enough clarity to show a single vehicle on a road. Pilots of the 7th Photographic Reconnaissance Group based in Mount Farm, England, flew dangerous solo missions deep over enemy territory. Unlike bomber crews, they carried no defensive armament. Their survival depended entirely on altitude, speed, and invisibility. Each sortie followed an exacting flight path, straight lines flown at constant altitude and overlap ratios calculated by the engineers at Medmenham. A single deviation could ruin an entire mosaic sequence. When the aircraft returned, the film canisters were whisked away to darkrooms where technicians worked in near silence. The negatives were developed, contact printed, and paired with matching frames for stereoscopic analysis. Teams of interpreters, many of them women trained in mathematics and geometry, spent hours examining terrain under stereoscopes. Using parallax, the minute difference between two overlapping images, they calculated precise ground elevations and measured everything from fortifications to flooded fields. The process was scientific but also profoundly human. Every photograph was studied by trained eyes, every anomaly questioned. A faint shadow might reveal a camouflaged gun, a subtle pattern in soil could expose a minefield. Each discovery added to the growing Allied map library, an immense, living archive of the European theatre. The results were astonishing. By mid-1943, Project Casey Jones had produced photographic coverage of France, Belgium, and the Netherlands at scales of 1:25,000 and 1:10,000, accurate enough for gunnery targeting and engineering construction. The aerial maps revealed terrain features never before recorded, from hidden roads to the geometry of coastal defences. As one British analyst later recalled, we could see Europe breathing beneath the clouds. To the planners of Operation Overlord, those maps became more than intelligence, they were the ground itself, measured and understood before a single soldier set foot on French soil. The Luftwaffe, meanwhile, knew none of this. German reconnaissance missions were still producing photographs, but without the integrated photogrammetric systems the Allies had perfected. When the first Allied troops landed on Normandy's beaches in June 1944, their maps were printed directly from this photographic data. The German defenders fought with charts drawn years earlier. And in that difference, in the clarity of vision, lay one of the quietest but most decisive advantages of the Second World War. 30 miles west of London, tucked between the River Thames and the gentle hills of Buckinghamshire, stood Danesfield House, a stately mansion that wartime secrecy had transformed into something extraordinary. To the untrained eye, it looked like a country estate. To those who worked within its halls, it was the beating heart of Allied aerial intelligence, RAF Medmenham, officially known as the Allied Central Interpretation Unit. Every morning, military trucks rolled through the gates, carrying sealed canisters of film fresh from reconnaissance flights. Inside, the corridors smelled faintly of developer and acetate. Hundreds of officers and civilians, mathematicians, engineers, geographers, and artists moved through narrow hallways lined with maps and photographs. The atmosphere was part laboratory, part newsroom, part monastery. Silence ruled, broken only by the hum of projectors and the faint scratching of pencils on acetate sheets. At the core of Medmenham's operation were the stereoscopic interpreters, analysts trained to read the world in 3 dimensions. Each sat at a light table with 2 overlapping photographs mounted beneath a special optical viewer. When the images were aligned correctly, they produced an illusion of depth so convincing that a trained observer could measure a hill's height to within a meter. From that principle came the Allies' most accurate wartime maps. The method relied on precise geometry. The first image was taken as an aircraft passed over a target, the second, moments later, captured the same area from a slightly different angle. The slight displacement between the 2 frames, the parallax, contained information about elevation and distance. Using mechanical calculators and plotting devices, interpreters transformed these shadows of light into topographic truth. It was meticulous, exhausting work. Analysts often studied hundreds of frames a day, their eyes straining under dim red lamps designed to protect delicate negatives. Yet the discoveries made in those rooms shaped every major Allied operation after 1942. From Medmenham's second-floor map room came the confirmation of the VIR-1 flying bomb launch sites in northern France, the identification of hidden submarine pens along the Atlantic coast, and the detailed planning charts for the D-Day beaches. Among the interpreters was Constance Babington Smith, a former journalist and pilot who became one of the unsung pioneers of photographic intelligence. Her team's discovery of the first VIR-1 launch ramp, revealed only by the peculiar shadows of scaffolding on film, directly influenced the Allied bombing campaign that neutralized the threat before D-Day. As Babington Smith later recalled, "We had learned to think not in lines and colors, but in volumes of light." The tools of Medmenham were equally advanced. Multiplex projectors, imported from American manufacturers like Fairchild and Kelsch, allowed teams to project pairs of images onto plotting tables, tracing contours and producing relief maps faster than ever before. Each finished sheet combined thousands of measurements into a single coherent picture of the battlefield. Visitors from the U.S. Army Map Service were astonished by the scale of the operation. The facility ran 24 hours a day, processing as many as 25,000 photographs daily. The data flowed to command centers in London and Washington via courier aircraft, where it informed the massive pre-invasion map libraries assembled for Overlord. By mid-1944, Medmenham had become a city of maps, a living organism of paper, film, and calculation. Every river bend, every hedgerow, every rooftop in northern France had been seen, measured, and recorded. When German officers later examined captured Allied maps after the invasion, what astonished them most was not merely the detail, but the consistency. Each sheet was perfectly aligned, every coordinate traceable to the next. What they held in their hands was the product of Medmenham's quiet miracle, an entire continent mapped by mathematics and the eyes of a machine. By 1944, aerial reconnaissance had become an industrial process, an operation of staggering complexity that spanned 2 continents. What began as an experiment in geometry and photography had evolved into a logistical empire of planes, cameras, and printing presses, all synchronized to transform the chaos of war into measurable data. The Allies had built not just intelligence units, but factories of vision. In the United States, the Army Map Service, AMS, operated from massive facilities in Washington, D.C., and St. Louis. Here, thousands of technicians translated raw reconnaissance film into military-grade maps at unprecedented speed. Shipments of negatives arrived daily from Britain, North Africa, and the Mediterranean. The film was indexed, labeled, and divided into sectors corresponding to specific operational theaters. Teams of draftsmen, photogrammetrists, and engravers worked in shifts around the clock, producing millions of sheets under designations such as GSGS 4347 and AMS M661. Each stage of production was a blend of craftsmanship and science. Cartographers traced coastlines with hair-thin precision, mathematicians recalculated elevation data using stereoscopic readings, lithographers transferred the finished lines onto metal plates for high-volume printing. The noise of presses filled the halls, a mechanical heartbeat that kept pace with the front lines thousands of miles away. Across the Atlantic, in Britain, the same transformation was underway. The Ordnance Survey, long known for its peacetime maps of the countryside, had been absorbed into the war effort. Its printing facilities at Chessington and Southampton were repurposed into military production lines capable of producing over 3 million maps per month. The paper came from Canadian pulp mills, the ink from secret chemical mixtures designed to resist moisture and wear. Every map that rolled off the press carried the signatures of unseen collaborations, reconnaissance pilots who risked their lives for each photograph, analysts at Medmenham who measured the terrain, and technicians who etched those calculations into copper plates. The result was an intelligence network unlike anything the world had known, a fusion of art, mathematics, and mass production. Among the most advanced devices used in this system were the Kells plotter and the multiplex stereo comparator. These machines allowed interpreters to project paired photographs in 3 dimensions and trace accurate contour lines directly onto acetate sheets. A skilled operator could process an area of 10 square miles in a single shift, generating maps that were accurate to within a few feet. The data was then transmitted to the Supreme Headquarters Allied Expeditionary Force, SHAEF, for operational planning. Every division preparing for D-Day relied on these maps. Engineers studied beach gradients derived from aerial triangulation to determine where tanks could land. Artillery officers used elevation data to program fire missions before setting foot in France. Even medics received detailed terrain charts to plan field hospitals away from flood zones. Meanwhile, the Luftwaffe's mapping divisions, once considered leaders in aerial reconnaissance, were faltering. Allied bombing had disrupted their photographic laboratories at Oranienburg and Potsdam. Film stock was rationed, chemical supplies dwindled, and trained analysts were reassigned to other duties. German maps of France still relied on pre-war French surveys, some dating to the 1920s. Against the Allies' living, breathing map of Europe, the Axis now navigated in partial blindness. By mid-1944, the Allies' photogrammetric network had become self-sustaining. Reconnaissance aircraft flew, films arrived, maps rolled off the presses, and within days, those sheets were in the hands of commanders at the front. It was the first true data supply chain in military history. Behind every advance across France and Belgium stood this invisible army of mapmakers, scientists, pilots, and printers who never fired a shot, yet defined where every shot would land. In late June 1944, just weeks after the Allied landings in Normandy, fragments of abandoned American equipment began to fall into German hands. Among the captured materials were the maps, folded, marked with grease pencils, and stored in canvas satchels stamped U.S. Army Map Service, restricted. To the German officers who opened them, these were more than simple charts. They were evidence of something profoundly unsettling. At a Luftwaffe field intelligence unit near Chartres, several of these captured maps were spread out on a table for examination. Present were officers from the Luftnachrichten Regiment 211, veterans of reconnaissance analysis who had spent years interpreting air photographs for the Reich's military planners. They were accustomed to precision, to the art of reading shadows and perspective. Yet as they compared the Allied maps to their own, a silence fell across the room. The American sheets were too perfect. Every contour matched the Earth itself with uncanny accuracy. The thickness of a hedgerow, the curvature of a field, the placement of a single farmhouse, each appeared exactly as it existed in reality. There were no hand-drawn approximations, no errors of alignment, no visible signs of human drafting. Even the color gradients for elevation looked more like mechanical renderings than traditional cartography. Oberst Hans Seidmann, a senior Luftwaffe staff officer who reviewed the material, later recalled that the maps exhibited a geometrical precision unknown to our methods. Others suspected that the Allies had obtained French civil data through espionage. But closer inspection proved that many features depicted new roads, bomb craters, destroyed bridges, were post-war updates, impossible to have come from old French archives. Then came the revelation: small printed notes at the margins of the sheets read source, photogrammetric compilation, AF reconnaissance. It was the first time most of these officers had encountered the word photogrammetry. They had known of aerial photography, of course, but only as reconnaissance, a tool for finding targets, not for building the very maps on which wars were fought. As they traced the grid lines with their fingers, realization set in. These maps had not been drawn by surveyors at all. They were built by airplanes. The shock was technical but also deeply psychological. For years, the Luftwaffe had prided itself on superiority in the air. German reconnaissance aircraft like the Junkers Ju-88D and Messerschmitt Bf-110 had pioneered long-range photo missions over Britain and the Soviet Union. But the Allies had transcended that competition entirely. They had turned the act of seeing into an industrial science. In an internal memorandum preserved in the Bundesarchiv Militärarchiv, one Luftwaffe analyst described the discovery as the mechanization of perception. The Americans and British, he wrote, have converted the human eye into a factory process. To German staff accustomed to traditional surveying, it was as though the Allies possessed an artificial intelligence, a machine that could observe, measure, and recreate the Earth faster than humanly possible. As more captured maps arrived from retreating fronts in Normandy, this realization hardened into a grim truth. The Allies not only knew where German units were but also how the ground beneath them looked. Rivers, ridgelines, and road gradients were already charted with a precision that left no room for tactical surprise. The Luftwaffe had once ruled the skies through speed and daring. Now the Allies ruled it through clarity. What began as curiosity soon became a source of alarm at the highest levels of the German command. For the first time, the Reich understood that the war for the air was no longer about flight, it was about vision. By the autumn of 1944, the Luftwaffe's cartographic divisions were struggling to maintain even basic mapping operations. Allied bombers had systematically destroyed the infrastructure that supported German reconnaissance, fuel depots, film laboratories, and printing plants. The great Luftbildämter, or aerial photography offices, in Oranienburg and Potsdam lay in ruins. Film stock, once supplied in abundance by Agfa, was now rationed to a fraction of its former volume. The Reich's photogrammetric instruments, precision devices made by Zeiss and Wild Heerbrugg, were packed into crates and relocated to makeshift facilities in Bavaria. The situation on the ground made matters worse. Field units in France and the Low Countries were constantly in retreat. Their photographic archives, once neatly catalogued in cabinets, were burned or abandoned to prevent capture. What had once been a technical edge, Germany's reputation for exacting engineering, was dissolving under the weight of logistical collapse. Against this backdrop, the Allies' mapping machine reached its zenith. The Army Map Service and the Royal Engineers Survey Corps were now updating their maps on a weekly basis. Newly captured aerial photographs were processed in England and France, then printed in the millions on mobile presses that followed the armies eastward. Commanders could request fresh sheets of terrain only days after a region was liberated. German intelligence could no longer comprehend how the Allies' maps changed so quickly, believing it must involve vast espionage networks or stolen archives. In reality, the explanation was simple but revolutionary. The Allies had achieved full photogrammetric automation. Devices like the Kells plotter and multiplex stereo comparator transformed overlapping photographs into contour lines almost instantaneously. Skilled operators could process square miles of terrain in a single shift. The Luftwaffe, still dependent on manual drafting, could not compete. During the Battle of the Bulge, the consequences of the disparity became undeniable. When German forces launched their surprise counteroffensive through the Ardennes in December 1944, their maps were outdated. Rivers had changed course after autumn floods, bridges had been destroyed by retreating units. American divisions, on the other hand, fought with fresh photogrammetric charts showing not only the terrain but even the density of snow-covered forests, data derived from subtle variations in aerial shading. Allied artillery used these elevation maps to target German armor hidden beneath the pines. German field commanders began to complain that their units were fighting blind. Reports to the General Staff in Berlin noted that American divisions seemed to anticipate ambushes, avoiding bogs and ravines invisible to the naked eye. What the Wehrmacht called uncanny intuition was simply superior mapping. The Allies were fighting from a three-dimensional reconstruction of the battlefield, one built from their reconnaissance cameras. When engineers at the remaining Luftwaffe Technical School in Oberammergau examined more captured Allied maps, they made one final, painful admission. In a post-war testimony later catalogued by the Technische Hochschule München, an officer wrote, "We recognized then that the enemy possessed a total integration of vision and mathematics. Their cameras were no longer for observation, but for creation. They had built an image of Europe more complete than any we could imagine." By 1945, the Luftwaffe's mapping bureaus were all but paralyzed. Without fuel, without film, without stable laboratories, they reverted to sketching by hand from outdated archives. The Allies, meanwhile, had turned cartography into a weapon system, fast, mechanized, and relentlessly precise. In that final winter of the war, as Allied armies advanced toward the Rhine, German officers understood that their maps told the story of their own defeat. The age of handcrafted geography was ending. In its place stood a new vision of war, one measured not in courage or territory, but in pixels of light and the mathematics of flight. When Germany capitulated in May 1945, the guns fell silent, but the lenses did not. The Allied reconnaissance squadrons that had mapped Europe from the skies now turned their cameras toward the aftermath, photographing ruined cities, broken bridges, and the reshaped landscapes of a continent at war's end. Yet these flights were no longer for invasion or bombing raids. They were for understanding. The same technology that had given the Allies a decisive wartime advantage would now become the foundation for rebuilding the world. The Army Map Service, AMS, and the Royal Engineers Survey Corps faced a monumental task to remap Europe not for destruction, but for peace. Entire regions had been erased by bombing or flooded by retreated armies. Rail lines had shifted, coastlines were littered with wreckage, and cities like Hamburg, Dresden, and Warsaw were little more than outlines of rubble. In these conditions, pre-war charts were useless. A new map of Europe was needed, one that reflected the altered reality of 1945. So the work continued almost seamlessly. Photographic reconnaissance units that had once flown over enemy territory now operated under the banners of the occupation forces and the Allied control commissions. In Germany, aerial mapping missions were carried out daily by the US Air Force and the Royal Air Force, documenting war damage, identifying unexploded ordnance, and surveying sites for reconstruction. Each photograph was an act of renewal, transforming devastation into data. The Americans quickly realized that their wartime photogrammetric infrastructure could serve civilian science and global security alike. In 1946, the U.S. Army Corps of Engineers initiated the European Recovery Mapping Program, using leftover reconnaissance film to create high-resolution topographic maps for the Marshall Plan. These maps became essential for rebuilding roads, power lines, and urban planning across Western Europe. The Air Force's photographic laboratory at Medmenham, still intact, was repurposed for civilian aerial surveys. But the most significant development came in the United States. Wartime research had unified dozens of small military and civilian cartographic departments into a single, modernized system. From that lineage emerged the Aeronautical Chart and Information Center, ACIC, and, later, the Defense Mapping Agency, DMA, the direct ancestors of today's National Geospatial Intelligence Agency, NGA. What began as a military experiment in seeing from above had evolved into a permanent branch of statecraft, the systematic observation of the planet. At the same time, the scientific legacy of the Allied mapping revolution began spreading across the world. Universities that had contributed to wartime photogrammetry, like the Massachusetts Institute of Technology, Cambridge University, and the Technische Hochschule München, continued to refine the methods for peacetime use. Professors who had served as military photogrammetrists published manuals that became the foundation of modern geodesy. In 1946, Kenneth A. Berger's seminal paper Photogrammetric Mapping in War described, for the first time, how aerial photographs could generate large-scale maps without direct ground measurement. It was the codification of the very technique that had astonished the Luftwaffe 2 years earlier. Meanwhile, captured German experts, many of whom had analyzed the Allied maps with or in 1944, were themselves absorbed into Allied research under Operation Paperclip and Operation Surgeon. Among them were optical engineers and geodesists from Zeiss and the Reich Geodetic Institute, whose wartime experience in precision measurement proved invaluable to the Allies' emerging Cold War ambitions. Their expertise in high-altitude optics helped advance the next generation of aerial survey cameras used by the United States. The work also crossed into intelligence. In 1947, as tensions with the Soviet Union deepened, the newly formed U.S. Air Force recognized that its most valuable peacetime weapon was information about terrain. Air Force Chief of Staff General Carl Spaatz authorized the continuation of aerial mapping flights over friendly and neutral territories, extending the photogrammetric grid far beyond Europe, to the Middle East, Africa, and Asia. In many ways, the war had not ended, it had simply changed medium. The battlefield of 1944 had become the global map of 1946. The same precision that guided paratroopers to the hedgerows of Normandy was now charting the deserts of Arabia and the mountain ranges of Korea. From destruction came a new discipline, geospatial intelligence, born from the same cameras that once stared down through clouds over France. It was a transformation that redefined not only warfare but humanity's relationship with its own planet. And in the silent laboratories of Washington and London, one truth became evident: the greatest legacy of the mapping war was not victory, but vision. By the early 1950s, less than a decade after the fall of Berlin, the techniques that had once mapped the hedgerows of Normandy were reaching for the stratosphere. Photogrammetry, the science that had astonished the Luftwaffe, became the foundation for a new frontier: reconnaissance from space. What began as a wartime necessity was now driving the scientific and geopolitical race of the Cold War. The first transformation came through the marriage of film and flight at unprecedented altitudes. During the Korean War, the U.S. Air Force Strategic Air Command revived and expanded the aerial mapping systems pioneered in Europe. Modified RB-36 Peacemakers and U-2 reconnaissance aircraft carried cameras derived from the wartime Fairchild series, their lenses capable of photographing targets from 70,000 feet. The precision of these images, when analyzed through stereoscopic instruments, matched the accuracy once achieved only at low altitudes during World War II. The photogrammetric revolution had gone global. At the same time, the infrastructure built by wartime mapmakers evolved into permanent institutions. The Defense Mapping Agency, DMA, inherited the vast archives of the Army Map Service and began compiling the World Geodetic System, a unified coordinate framework that allowed military and civilian aircraft to navigate using the same mathematical grid. This effort, born from the Allied drive to measure every contour of Europe, eventually became the backbone of global positioning. The work of wartime scientists, once hidden behind classified doors, quietly reshaped everyday geography. In Britain, RAF Medmenham continued its transformation. Rechristened the Joint Air Reconnaissance Intelligence Centre, JARIC, it remained a hub of photographic interpretation through the 1950s and beyond. Many of its wartime veterans, men and women who had once studied film strips of French coastlines, now examined photographs of nuclear test sites, missile silos, and Soviet airfields. The discipline they had refined in wartime Europe became the central nervous system of Cold War intelligence. Germany, too, carried forward lessons learned from defeat. The post-war Bundesamt für Kartografie und Geodäsie, Federal Agency for Cartography and Geodesy, rebuilt its mapping capabilities using Allied photogrammetric techniques. The same universities that once supported Luftwaffe mapping now trained a new generation of scientists for peaceful applications, civil engineering, urban planning, and environmental monitoring. The technology that had once served conquest was now serving reconstruction. But the greatest leap came from orbit. In 1957, the Soviet launch of Sputnik ignited an international race to observe Earth from beyond the atmosphere. The United States responded with Corona, the first satellite reconnaissance program. Its cameras, designed by engineers who traced their lineage to wartime photogrammetry, photographed the globe with precision unimaginable only a decade earlier. Each image capsule parachuted back to Earth, its film reels revealing entire continents in detail once limited to small sections of France. By the 1960s, photogrammetry had evolved into remote sensing, the gathering of geographic information from aircraft and satellites using not just cameras but radar and infrared. The principles remain the same: overlapping images, measured geometry, and the transformation of light into data. The revolution that began with Allied reconnaissance pilots flying F-5 Lightnings over Normandy had become the basis of global Earth observation. What had once shocked German officers as a mysterious secret was now a universal language. Engineers, scientists, and navigators across the world spoke in coordinates and grids, in elevation and parallax. Humanity was learning to understand its planet as a measurable system, every mountain, forest, and city mapped not by exploration, but by vision. The echoes of that wartime breakthrough are everywhere. Every civilian airliner that follows a GPS route, every satellite map on a phone screen, every environmental study built on aerial imagery, all trace their ancestry to those Allied operations between 1943 and 1945. In 1944, German officers had stared in disbelief at maps, too perfect to have been drawn by men. They were right. Those maps were the beginning of something greater than war, the beginning of humanity seeing itself from above. The war for the skies had ended, but the age of vision had only just begun. When the war ended, much of the world believed the story of flight had reached its conclusion. The fighter aces had vanished into history, the bombers stood silent on cracked runways, and the soldiers returned home. But above the ruins, a quieter legacy remained, one built not on speed or firepower, but on vision. It began in secret rooms like Medmenham, in the long shadows cast by light tables, where analysts bent over strips of silver film to reconstruct the world. It continued in the humming halls of the Army Map Service, where draftsmen transformed those photographs into the maps that guided armies, rebuilt nations, and, eventually, connected continents. From those rooms came a revolution that no one had set out to create, a revolution in how humankind would see itself. The German officers who once unrolled the captured Allied maps in 1944 could not have known that they were witnessing the birth of a new way of knowing. They saw the immediate power, the precision that allowed paratroopers to land in darkness, that guided artillery without sight, that turned reconnaissance into command. But beyond that, they glimpsed something much deeper, the moment when technology began to replace perception. When machines no longer simply extended human eyes, they surpassed them. In that revelation lay the future. From the skies above Normandy to the satellites orbiting the Earth, the idea remained constant: knowledge begins with seeing. The Allies had proven that mastery of the visual world, the power to measure, to model, to predict, could win wars. In peace, that same mastery would chart continents, map oceans, and peer into the stars. The moral dimension of this transformation is complex. The tools of photogrammetry were born in war, in the service of precision bombing, invasion planning, and destruction. Yet, like so many military technologies, they transcended their origins. The same stereoscopic techniques that once revealed hidden bunkers later measured crop yields, planned highways, and monitored the melting of glacier. What had been an instrument of domination became an instrument of understanding. Still, something of that wartime intensity lingers in the science of vision. Every satellite image, every aerial survey, carries an echo of those first reconnaissance flights, a reminder that the impulse to see, to record, and to know, often begins in fear. The men and women who perfected aerial mapping did so not for curiosity but for survival. Their work revealed an uncomfortable truth: to control the world, one must first see it completely. Today, the descendants of those wartime maps lie not in archives but in the digital fabric of modern life. Global navigation systems trace their mathematical roots to the World Geodetic System, born from Allied photogrammetry. Weather satellites, geological surveys, even the streaming maps we use to find a street or measure a field, all inherit their logic from those wartime lenses. The same geometric equations that once guided a reconnaissance pilot over France now guide spacecraft around Mars. And yet, behind the precision and technology, there remains the same fragile human intention. In 1944, when those Luftwaffe officers stared at the American maps and whispered, "No man could draw this so precisely," they were both right and wrong. The maps had not been drawn by human hands, but they had been imagined, calibrated, and assembled by human minds, by thousands of individuals whose names are barely remembered. Pilots who flew unarmed through flak-filled skies. Mathematicians who calculated parallax shifts by hand. Analysts who measured the shadows of bridges under candlelight. Their collective labor changed not only warfare but the boundaries of human perception itself. From the trenches of the First World War to the satellites of the 21st, the pursuit of sight has defined our century. It is a paradoxical inheritance, born of conflict, perfected in secrecy, and now woven into every aspect of civilian life. The modern world's ability to measure itself, to see itself, and to predict its own motion owes everything to those years when nations mapped each other from the clouds. In that sense, the maps that stunned German intelligence in 1944 were more than tools of war. They were the first mirrors humanity ever held up to the earth, precise, mechanical, and mercilessly objective. They allowed us, for the first time, to step outside ourselves and see the planet as it truly was. And from that vantage point, everything changed.